So now we continue with internal rate of return. This is the second investment appraisal method, which uses the concept of discounting. So for starters, what is internal rate of return? Definition: internal rate of return is simply a discount rate which gives an NPV of 0 and is estimated using the following formula. So really this is a discount rate at which when you discount all your cash flows, you get an NPV of 0. How do you estimate internal rate of return? You need 4 variables, 2 discount rates, 2 NPVs. You have a lower discount rate which will give you a positive NPV, and a higher discount rate which will give you a lower NPV or negative NPV. So then, when you're given a question, how do you set about choosing the discount rates? Well, like the question that you are looking at, you already had one discount rate of 10%. So in that case, all you do is you are saying at 10% have a positive value. So preferably, I'm looking for a negative value. So what do? You increase your discount rate, and at a higher discount rate, preferably you would get a negative NPV. 20% is quite good to use because the discount tables that you use in your examinations have got the highest rate of 20%. So once you have 2 discount rates, 2 NPVs, then you can estimate the internal rate of return. And that is what we are going to do now. We're going to estimate the internal rate of return. We already have data, remember, at 10%, we already have this as our NPV. So since at 10% we have a positive, we'll push that up to 20% and get a second NPV, which hopefully will be a negative. So here we are. If we discount the same cash flows at 20%, we now have a negative NPV. So now we have got 2 discount rates and 2 NPVs, and therefore now we can use our formula to calculate the internal rate of return. So as you can see, our low discount rate 10, high discount rate 20, and the negative NPV at the high discount rate of 20 is 17.95, and the NPV at the low discount rate is at 8.06. And once you put this in the formula, then you've got an internal rate of return of 16.8%. How do you use this figure? Well, the simple rule is you accept projects whose internal rate of return exceeds the company's cost of capital. That is what you do. So you compare your internal rate of return with the company's discount rate or cost of capital, and you only accept projects where the internal rate of return exceeds the company's cost of capital. In investment appraisal, also, your syllabus expects you to know how to discount annuities. You should know how to discount an annuity. So what is an annuity? Well, an annuity is a constant cash flow arising over a specific period of time. So an equal cash flow over a specific number of years. But here's the point. How do you discount the annuity? You simply use an annuity factor. Let's take an example to illustrate this. We have an investment here which involves $250,000, $250, and which generates an equal amount of $70 over a 5-year period. So this investment will generate what we call an annuity. So then, how do we discount this figure? Well, 2 approaches. One can argue that I can still do what we have done before. So we can discount just like we've done before. We can discount these cash flows one after another, get 15.36. But the examiner doesn't expect us to take this approach because sometimes you can have annuities over a longer period of time, like 15 years, 16, 17 years. You can't go line for line. You're going to spend all your time on a single question. What the examiner expects us to do is to use an annuity factor. And an annuity factor really is these values, the cumulative present values, this figure, that one, plus that one, plus that one, plus that one, plus that one, giving us 3.791. That's what we call an annuity factor, and that is what we use. On the tables also that you use, you can also pick an annuity factor there. Just go to 10%, look at year 5, and then you find the value of 3.791. So the approach that the examiner expects us to use for prepared candidates is that we're supposed to summarize our computation like this. So what it means now is that year 0 will be along year 1 to 5. We discount it just in one line by multiplying 70 by the annuity factor. And then you've got 15.36. The same figure that we found even here, 15.36, but the examiner expects us to take that shorter approach. We've got another cash flow called a perpetuity. What is perpetuity? This is a constant cash flow arising forever. So the same figure arising for the foreseeable future forever. The point again is, how do we discount such a figure? The answer is, a perpetuity is discounted by dividing, okay, that perpetuity or constant cash flow by relevant discount rate. Example. Given a relevant discount rate of 10%, estimate the present value of $10 receivable forever. So you have a perpetuity here of $10. How would you discount it because it will arise forever? The answer is you simply divide $10 by 10%, or as shown in this slide there, $10 divided by 10% giving you $100. So the present value, $10, receivable forever at 10% interest rate is $100. So then we have looked at the internal rate of return in this portion, and also perpetuities and annuities. And what we expect you to do now is to practice a question, and there's two questions we practiced here. That question is on internal rate of return, which you can do. Then we've got another question here, identify and explain advantages and disadvantages of the NPV and internal rate of return methods of appraisal. So next time around, I'll take NPV, and now I'll look at the treatment of taxation, the treatment of inflation, the treatment of risk and uncertainty, and also how to treat working capital in NPV computations. So be on the lookout for this posting.